This is the Blueprint Podcast, bringing you the latest in cyber defense and security operations from top Blue Team leaders. Blueprint is brought to you by the SANS Institute and is hosted by SANS Senior Instructor John Hubbard. And now, here's your host, John Hubbard.
If you're confused about AI and ML and how it applies to information security, believe me, you are not alone. In fact, our previous episode on the topic was one of our most downloaded episodes so far. So this week, we're bringing you more. On this episode of Blueprint, I talk with Dave Hoelzer to separate the hype from the truth about what machine learning can do for you and your team. Stick around. Hello, everyone. Welcome to the Blueprint Podcast. Today on the show, we have Dave Hoelzer, who is the COO of Enclave Forensics and a SANS Institute Fellow, which is the absolutely highest designation we have for someone working at SANS. So he's been around for a long time and really knows his stuff. Really excited to have him on the podcast today. So welcome to the podcast, Dave.
Hey, thank you very much, John. And, I'm going to take the E out of that. Otherwise, I'll get in trouble with the actual CEO. But I'm the COO, so I'm the operations chief at Enclave.
Gotcha. Awesome. So to start it off, one of the things I wanted to talk about, obviously, on this podcast is machine learning and AI and all of that. And you were sitting right in the middle of a whole bunch of exciting activity and classes and things kind of in that space. Before we launch into that, though, I'd love to hear kind of your background and what it is that brought you to jump into that and kind of embrace that space.
Yeah, absolutely. I've been in this field for quite a long time. And by this field, I don't mean AI. I mean, I've been in the cybersecurity or information security. We keep every 5 years, we rename this field. But I've been doing this since around the mid-1990s. And back when we got started in that, there really weren't any tools you'd go buy. You could go buy antivirus, but that was about it. So pretty much everything else, you had to do it yourself or put together a team to make humans do it. And I've been doing that for a very long time. And one of the things that started to emerge for me around 2012, 2015, is seeing the advances that were happening in machine learning, given some things that were happening with artificial intelligence and neural networks, and beginning to think about how I might be able to use that within my business to not to replace people, but instead to accelerate the work they do and to let my people get more work done faster through that stuff. So I've been kind of standing in that space since then, both on the research and on the application side within our business. Very
cool. So with the things that you have seen, I assume you've done all kinds of detection and kind of just process improvement related, maybe AI and kind of all of that. I'd love to touch kind of on all of those use cases. Before we get into the specifics on that, one of the things I think confuses a lot of people, myself included, because like I said before this, I'm not an expert at all in this either. So I'm probably coming at this as naive as anyone else. AI versus ML versus anything else. I know there's overlapping Venn diagrams and all of that. Is there a specific scope of where you find information security solutions falling? Is it a little bit of both? Is it one within the other? Where do we kind of start this conversation?
Yeah, it's a super question, John. And you're right. It's so confusing because you'll even find that while there are those Venn diagrams out there, even within the space, people will use the words differently. We do tend to say that machine learning is a much broader thing where artificial intelligence is perhaps narrower. But even then, the way we apply that just depends because one of the things I try to get across to people, I've done this both with executive teams, I do this within the classes that I teach, in the class we wrote for this stuff, is trying to give people an aha moment where they can see that all of this stuff we call artificial intelligence, all this stuff we call machine learning, regardless what bin you want to put it into, it ultimately is just math. And that really flies in the face of what people feel like they see. Because when you watch for instance, the DeepMind team did an absolutely wonderful documentary on AlphaGo. And AlphaGo is old at this point. They've gone way beyond that. But it's amazing because you start thinking that it's reasoning and thinking about things. And it's just not. It's just math. So in the end, it's just algorithms that are able to improve performance over time based on the math. That's it.
Is this a thing where the algorithms we're trying to improve, are we detecting stuff? I guess this is detection use case scoped, but are we detecting things better? Are we detecting new things? And that's just kind of within the detection realm. And I guess the same kind of question for process improvements as well. Like, is this breaking new ground or is this helping us improve what we're already doing, or both?
Yeah, that's a great question. And so let me relate that in two ways. On the one side, in the alpha, I think this is actually the Alpha Zero team who's been working on doing some additional stuff and doing reinforcement learning with algorithms without giving it any information. In other words, it's not learning based on human experience. It's just learning on its own. It's competing against itself. And this is all done in games right now. So there's not a lot in terms of detection that I would point this to. But what they're finding is when they take that system and they have it, for instance, learn to play a game like chess, not only will it get to superhuman capability, but it will actually play that game unlike any human would ever play that game. In other words, it will use strategies that humans over thousands of years have kind of looked at and dismissed and wouldn't even think of playing because we as a human would look and say that just won't work. But it doesn't have those preconceptions, and it ends up being an effective strategy you and I would never come up with. So that's in the application of games. What I find in our space is that it's really taking a massive probability space and giving us a way to not so much search it, but be able to get outcomes out of that probability space where it doesn't have the domain knowledge you or I have, where we would approach a problem in a certain way. And if I said, hey, go find a threat. So if I asked you, take an employee, teach them how to find a threat, you'd give them a series of things to look for, and they'd learn how to find a threat the way a human would look. When I take and apply these machine learning techniques to it, I can try to use my domain knowledge to get it to look for threats the way I do, but I personally avoid that as much as is possible, because then it's just taking my human bias with it and taking my human approach. But if instead I say, hey, listen, here's some stuff, tell me what the 10 most interesting things in that stuff are, well, some of that stuff might actually be threats. And it's found a threat a way I never would have looked. The tricky thing is, how did it find that threat? Because, and this goes back to the whole thing about, can we describe how an AI works, and can we really explain, or explainable AI, which is kind of the one of the golden or what's the word, the thing we're trying to get at. I can't think of the right word for that, but the golden whatever we'd love
the
to
end
capture.
game, the ultimate goal of
yeah we'd love to do that. And some AI is very explainable, but a lot of it just isn't, unless you have a lot of math, and even then it's just not provable. So I really do find it to be more an accelerator, and it can look at things in new ways, but I still need a human in there to look at it and say, oh, that is a threat. That's something we need to do something about.
Yeah. So one of the things I wanted to get into, and I think that kind of leads there, is how do we approach this in terms of are we throwing a bunch of data at it and we're doing kind of unsupervised machine learning? And it sounds like you're saying it's going to notice, clusters and whatever, of data that you're like, maybe you didn't notice that before because you didn't visualize it a certain way. And that itself now leads you maybe back to a way of detecting something that you couldn't detect before. With that, I'm kind of curious kind of how that process works, and also a little bit around how do we decide what is the right problem for machine learning, and what is maybe you discover those things, you're like, oh, we could do this a really simple way, but machine learning told us how to do it in a simple way. Is there a distinction there as well?
That's interesting. So I have a couple answers to that. It's a wonderful question, but there's so many angles to that question. There are a lot of folks who are approaching machine learning purely from the unsupervised point of view. So let me just qualify that, because I know you know what you mean when you ask that, but some of the listeners might not have any idea what that means. What that really means is, in machine learning, we can break it into two big bins. We could say it's supervised or unsupervised. And what the supervised is saying is, all right, machine, okay, algorithm, I have this problem I want you to solve. Here is the input data I'm going to give you, and I'm going to tell you what the answer should be based on that input data. And I'm going to give it mountains of input data with mountains of this is what that should result in, and see if it can work out how to make that happen. You could think of it in a simple way as, give it some information out of some math function, and I know what the output of that math function will be. I can plot that, but I'm not going to tell the algorithm what the math function is. I'm just going to say, here's the x's. That's what the y's look like. Work out what the function is. We can do that. That's supervised learning. Unsupervised learning is, here's a bunch of stuff. I have no idea what the outcomes of that stuff are. See if there are interesting groupings in that data. Unsupervised learning has some really interesting applications in our field, but it also has some huge challenges. One of the biggest ones is it requires a massive amount of data before it becomes useful. A very easy way to think about that is if you've ever taken a statistics class, then you were likely introduced to the notion of having to have enough of a population for you to find something of statistical significance. For example, if I poll 10 people coming out of a polling place when they've just voted in an election, and I ask them, hey, who'd you vote for? And based on that, I say 90%, this is who the next person's going to be that gets elected. I don't know, 10 people, is that a big enough sample? That could be a little bit skewed. So it's that same idea. And I have to have so much stuff. And that leads to this huge challenge. It's actually several. First, I don't know what's in there that's good or bad. So how do I know if it's right? And you could say, well, I'm going to give it data I know a lot about. But see, attacks are constantly evolving. So do you really know everything that's in there? Maybe it's finding something you don't know about. And then how much do I need? I have a customer who was talking to a vendor about putting in an AI solution to do threat hunting in their network. And they quoted some astronomical price. But the real showstopper for my client was when they said, and what we're expecting is this is going to need to run in your environment for about 6 to 8 months before you start to see any kind of useful output. Because it has to learn. And that's a huge obstacle. I don't have 6 months to wait. If I'm talking to you about threat hunting, I think I've got a threat now. And if that threat is active now, is that algorithm going to learn that threat is totally normal for me and not tell me about it? So we do use the unsupervised stuff, but we tend to do it in a much more constrained way. And I'm far more interested in taking problems that are frequently viewed as unsupervised problems, like anomaly detection, but solving them with supervised systems, because that I can make actionable with very little data, and I can get really useful outputs immediately that can run in real time.
So what kind of system, to make this like a practical example of things you've done that with, where have you taken, an unsupervised problem, an unsolvable, difficult thing, and then done that kind of approach and had some success with it?
Yeah, sure. Well, let me give you two, actually, a totally unsupervised problem. And let me give you one we converted into a supervised problem. I was talking to a gentleman, well, I don't want to say which agency it was, but it was a government agency. And don't think, oh, it must be the CIA. No, just a government agency. And they were trying to solve the problem of, we know for sure there's bad stuff happening. We feel like there's stuff in our DNS logs we could use to find that. So they're keeping track of all the queries that are run in their organization. But how do we do it? And they had been talking with a company that was trying to do supervised learning with that. And ironically, I'm usually trying to go towards supervised learning. But in this case, it was just the totally wrong approach, because it required you to have massive lists of known bad actors and what their domains are, which is just an intractable problem because it just keeps changing. So they had been working on this for months, and he and I sat down. We talked about it for an hour, and at the end of an hour, we had an unsupervised solution that would take all of their DNS stuff, tens of millions of queries, and spit out for him the top 12 interesting bins. And out of that, we instantly had a covert channel active in their network. There was an unknown threat to them. Wow. So, I mean, that's motivating, right? And just in the space of an hour, we can find a thing like that. Going the other way, when you talk about doing anomaly detection, data scientists, statisticians, machine learning people will almost immediately say, you need unsupervised learning, because that's what it's finding. It's finding anomalies. But for me, that's not useful. I need a thing with the work we do. We do monitoring of networks. I need to know what that is. Is it good or bad? Not just, is it different? So we've spent a great deal of time, particularly in the field of autoencoders and researching how to build scalable autoencoders to do real-time detection of anomalous communications on networks, encrypted or not, and identifying covert channels and other threat actors within networks that are just behaving in an unusual way. And again, we can do that kind of training usually in the space of about a week, rather than I need 6 to 8 months of your network data. And from that point on, it's just real-time detection and spitting out for you. There's an unusual thing occurring. So you can really do amazing things. It's about selecting the right tool for the right job.
So would it be fair to say that in a lot of cases you are using kind of machine learning techniques to highlight these things that pretty effectively, it sounds like, that are bad, but when you spit them out, right, like that the government agency example, when you were done with that, did that come up with a solution that you're like, oh, okay, now we can just turn that into a snort alert? Or was it like, we're going to have to keep running machine learning to keep finding this stuff?
Yeah, that's a very good point. So, and one of the things I look at machine learning and AI for is, again, being an accelerator within our field. Will we eventually be at a point where we can give some AI the ability to just run our network for us? Maybe. And there's varying opinions about what that will look like. And it's really headed toward this notion of artificial general intelligence, which some people will say, oh, I think we're a year away from that. I think we are decades at least away from that, because we frankly have no idea how human beings reason about things. So if we don't understand how we do it, how are we ever going to make an algorithm that does that? Which is why it's appropriate to say that we have machine intelligence today. We absolutely do. But it's very narrowly scoped, like AlphaGo. It can beat anyone in the world at Go, but it can't tell you how to tie your shoes. And you can't learn how to do that because that's not what it's designed to do.
Right.
So for me, these kinds of solutions, they're not something that's just going to give me the snort alert. They're something that runs in parallel. There's something that, for instance, if I'm sitting in a SOC and I'm a threat analyst, this is one of the tools that I have, not that I could just pull out and use, but much more so, one of the things that I'm using to build things that are telling me about what's happening in my environment. Mm-hmm. One of the things we spend a lot of time with in 595, for instance, we don't spend time in that class teaching you how to use vendors' AI solutions and how to build a classifier in the AI solution. Instead, what we do is teach only the fundamentals of math that you have to have. And even then, it's not like we're not sending you home with calculus problems as homework. It's not that kind of class. It's just kind of what the theory is. So you can then take the machine learning tools and say, I've got this idea of a way I'd like to look at my stuff. I think there could be something cool in there. Let me take this algorithm and apply it to that data. So you're really learning how to make that translation, how to apply modern techniques to data you already have to give you outputs that you might then look and say, again, those 12 classes we got for that agency, most of them were not particularly interesting. There's people getting ads. There's telemetry information from Google and Microsoft. Yeah, okay. Not great, but I'm not going to do anything about it. Oh, but wait, that one there, that's malware. So it still requires the human to look and say, oh, that's bad thing.
So it's an incredible noise reduction technique in a lot of
Absolutely.
ways, right? And that's kind of the impression that I've been getting of it. One of the things I wanted to build up to here in asking that question is this a technology that we should look at as, I don't know if this is maybe the best way of phrasing it, but it's what's coming to mind. Is this a tier 1 analyst substitute where it's going to be the first thing that says this might be a problem? Or is it going to be the tier 3 ultra mega super fancy detection that's way beyond all humans' ability to detect something and kind of add more complex detections? And it sounds like it's a little bit of both. And, given kind of the answer to that, if you're buying a product that's implementing this, what should we be looking for, and what kind of direction should we take it, as opposed to writing it ourselves, which is kind of a whole separate conversation there?
Yeah. As you were starting to ask that question, I was immediately thinking about vendors, because I think you're right on. I'm not sure this would be the T3 analyst. I mean, maybe someday we could make the AlphaGo of network security, but I don't think we're anywhere near that today. And the biggest reason is, you can take the reason there's so many advances around games isn't just because computer scientists like to play games. It's because they have a bounded universe and I can get the computer play itself. So there's a real opportunity for it to do learning, and it can do that learning very quickly because it's not dependent on anything outside that universe. But in network security and in computer security and monitoring networks, it can't do that. There's no way to create that bounded universe, and we're very much waiting upon actions of others, people on the network, attackers, normal users, all that stuff. So that's a very, very difficult problem, maybe someday. So I think the T1 analyst is a much better way to think about that. One of the things that we're actually trying right now to arrange for one of the customers to release a public data set for us. And we're going to have to do some sanitizing on it, because one of the big accelerators that we have found is taking machine learning and using it as the first pass through a help desk database. One of the things organizations struggle with is, you've got help desk tickets coming in. How long it's taking you to close them is often influenced just by how many you have. And the fact that the initial assignment of that ticket, if it doesn't go to the right person the first time, you're likely adding a week or more for that thing to get resolved, or if ever. So using machine learning to take a pass through help desk databases and things that were actually resolved, and now use it as a first pass for maybe doing triage on it. How important is this? The user said that it's critical because, every user will say that. But in the grand scheme of things that have happened before, this is probably a low priority. Or alternatively, when making the first assignment, rather than relying on a help desk manager to choose whose queue that goes into, it's now looking and saying, well, for this kind of problem, this person over here has the greatest or the fastest close rate or whatever, satisfaction, however you choose to measure it, and doing the initial assignment through that. Because again, getting it to the right person the first time leads to the greatest closure rate. So even practical things like that, where I don't believe it's going to be right all the time, but if that system were right 80% of the time, that's still better than waiting for the help desk manager to do it, who isn't 100% right anyway. So it's not, again, it's not replacing anybody today. It's about building systems to do that. And I'm sorry, I have to circle back because your question had to do with vendors, right?
Ultimately, yes, we'll build up to that. Yep.
So the big problem to me is one of the things we've suffered from in the AI space is we go into these AI winters. And the cause of an AI winter, which just means all the funding dries up, the cause of it is vendors who are over-promising and under-delivering. And then when corporations realize, you mean the expert system, I have to have someone reprogram it every 6 months? How is that helping me? And all the research dollars dry up. So my great fear in this space is that every vendor today is attaching machine learning or AI to everything they're selling. And if you just scratch the surface on that, quite frequently, there is no machine learning under it at all. So my big advice is make sure that you can have intelligent conversations with those vendors so you really know what it is they're selling you. And if under the hood they're saying, well, if it doesn't know how to classify it, we send it to a human who makes a determination, I really have to wonder how much AI is happening there.
If you've been with us through season 1 and 2, you've undoubtedly heard me talk about some of the courses that I've authored for SANS that are near and dear to my heart as a lifelong blue teamer. What you may not know is that every year and multiple times per year, these courses continue to get better. One of my favorite classes to teach is Sec 450 Blue Team Fundamentals, which is a technical class I designed for anyone working as a cybersecurity analyst for teams large or small. We continue to update the class and bring in new information on the newest threats, data, and protocols that any defender needs to be aware of. In the most recent course refresh that went live just about a month ago, I've continued to hone the content, diving further into cloud defense, automation examples, detection for modern attacks and attackers, including common things like ransomware and much more. And we've also brought increased focus on new and more difficult to monitor network protocols like HTTP2 and HTTP3, DNS over HTTPS, and TLS 1.3. things that every Blue team needs to be familiar with or will need to be very soon. Every version of this class comes with continued focus and updates, and this class is huge. I don't know of any other security operations course out there that contains nearly 1,000 pages of slides and notes, 15 hands-on labs with a virtual machine to go with them, including another 400 pages of step-by-step exercises for those hands-on exercises, video walkthroughs of all of those exercises, MP3s, a course wiki, and a whole day CTF where you can apply the skills you've learned in class throughout the week. My goal with this class is to bring you the absolute most comprehensive security operations and analysis course possible, and I'm continuing to strive with every release to keep updating the course and deliver on that mission. The depth of content in this course is something that SANS is uniquely positioned to deliver, and I hope you'll check it out if you have a free moment. Go to sans.org/sec450 to check out the free course demo, which is a free full section of the course, and an in-depth syllabus to see if it's right for you. We have options to take it live in person, live online, or at your own pace with SANS On Demand. And unlike some other training courses, SANS and I are there to help you along the way with personalized help and explanations for any questions you may have. With the recent release of the GIAC GSOC certification, anyone that takes the class can now get the corresponding certificate that shows that you've put in the work and have what it takes to go head-to-head with modern attackers. I really think we put together something special here, and I hope you check it out. Thanks for listening, and now on with the show. One of the things I was thinking about kind of before this conversation was, how to phrase, I think, what are the big questions that people are wondering? And one of the things I came up with was, very similar to what you just said, is like, when we're going to buy a product that claims machine learning, right? I think people approach the problem with, I hear about this advanced thing, I wonder what it can do for me. And I don't know if that's the right approach versus like going in saying, I have this problem and I want machine learning to solve it. Is there what's the smart way to go about this, right? Do you see people diving in and just like, I don't know, let's see what it detects? And I can tell you, as someone who has done that sort of approach with like UBA and that kind of stuff in the past, right? We did find stuff, right? It's like, oh, we hear about a technology, we put it in, it works. But had I, going back and thinking about what it found, and if I dove in with use cases like, do I need AI? Like how should people be approaching purchasing stuff like this? And I guess maybe this is a little bit the same question, but slightly differently. When they claim machine learning is, this is the special sauce in the product and you're buying it, do we evaluate that directly? Do we care? Or do we just care about like, does the product work better than what we have now? Like if it's if it's ML or AI and it sends it to a human, should we be trying to measure how much it's actually ML, or do we just like, hey, it works better, right? That's what we really care about here.
Yeah.
Where do we go with this?
Yeah, I think it depends on your goal, because there is a lot to be said for, frankly, I don't care what the sauce is as long as it works. So if it's better than what I have, that's good enough. And knowing that, everyone is going to call it machine learning today. So call it whatever you'd like to. I just want to know if it's better. And that is a very practical way to look at it. And frankly, that's what I'd recommend to a lot of people. Just ask yourself, is this going to make a marginal increase for your business? And given the price point, does that make sense? Mm-hmm. When I'm talking about organizations, though, who are really interested in threat hunting, so I'm being narrow, right? I'm staying with our space. Mm-hmm. If I'm talking about someone who's really interested in doing threat hunting, and I'm not interested in being able to find everything that all of the commercial tools can already find. I mean, I can buy something that does that. I need to know what else is happening. If that's what you're trying to do, I'm not sure I would be pointing you at buying a product. Now you're telling me that you have the resources to invest in security researchers. If you have a security research team, it makes a lot of sense to me that some of those people should be able to do strong data analytics and maybe machine learning and AI. Not that it will be a sea change for us, but it would create a way for me to accelerate stuff again. One of the things, take that idea of doing real-time classification and finding anomalies, right? One of the things that I talk to folks about, because we actually build that thing. We build that in 595. One of the things I talk to them about is when we get started with that, imagine I asked you, John, said, okay, hey, listen, it's Monday morning. Here's what I need from you. By the end of today, I need you to write a tool for me that will be able to tell me whenever there's SSH communication on the network. All right, so off you go, you research, you make that happen. And you come back to me on Tuesday, tool's done. And I say, that's great, John. Now what I'd like you to do, could you also add the ability to detect TLS data? All right, so you add that in. And then I say, can you add in SMB? Can you add in? Now, for the one-off, yeah, I can spend a couple of hours and write whatever you need. But the more things I need that thing to do, we rapidly get to a point where I say, if I point a neural network at that, I can solve all of those problems in the space of about 45 minutes. How is it doing it? Frankly, I just don't care. I know how to build it. I know the theory behind it, but I don't care why it made those decisions. I just care the decisions are right. So that's what I mean when I say accelerator. So investing in those security researchers and giving them the ability to make those tools that will accelerate their work, I think that that's invaluable. So it really just depends on where you are.
So I think I like that answer, because I think it kind of gets to where I was trying to separate with a, semi-formed question, which is, if you're buying a product, what should we expect it to do? And it sounds like the answer might be like, yeah, it can help you detect the things you already probably could have detected. But if you're buying it to detect brand new stuff that no one's ever thought of or seen before, like, maybe you get a product for that, but maybe that's not necessarily the right tool for that use case. And so it sounds like if you're trying to get into truly new detections and not just easier, lower the bar for what's already there, maybe going it on your own, learning some of this stuff is the path.
Yeah, and part of the reason for that, it's so I for instance, Security Onion. I love Security Onion. I love Doug Burke. He and I usually go down to get a well, there's a hot dog place down there in Augusta. So whenever I'm there, he and I go down and get a hot dog. But the dashboard in there is beautiful. But frankly, I never use that for threat hunting. And the reason is, it's a great dashboard. There's lots of things on it, dials and graphs, and it's beautiful to put on a wall so that when executives walk through, we can point at it and say, look, see, we're doing stuff. But every attacker, every advanced attacker knows exactly what shows up on that dashboard. And pretty much any tool you buy off the shelf that's going to do some threat hunting, well, those are all known quantities for any advanced attacker. So if that's really where your concern is, and knowing how easy it is to defeat and fool these tools, because of course, with a commercial tool, we are very careful about having false alerts, because a false alert is as bad as missing something, if not worse, because when there's a false alert, we say there's something wrong and there's nothing. Man, there's a lot of resources spent on that to find out nothing was wrong. It's almost safer for the commercial tool to not report anything and let a compromise happen. So with those pre-built tools, AI or not, knowing how they work, and since anyone has access to how they work, it means that finding the advanced attacker with those tools is not that reliable. A mutual friend of ours, John Strand from Black Hills Security, so they released this tool, Rita. It's a wonderful tool for doing retrospective analysis of time-based data to find threats, especially finding backdoors and compromises. But of course, you wouldn't be surprised to find out that if you hire Black Hills Security to do a pen test, when they pen test you and inevitably get in and install backdoors, Rita will never find them because they know how Rita works, and It's the same problem.
Yeah, that's a good point. The accessibility of the defensive tools, drives kind of the necessary need their need to do something completely unique. I'm sure there's a case, a good enough, it will catch basic attackers, but those really high impact, serious attackers, you may still miss that, and you need, alternative ways to go about it. So it sounds like that's maybe, the use case. If people, and everyone's trying to catch that, of course, but if people want to find a unique use case for ML that maybe can't be solved by other means, that's kind of the thing that you should be targeting. Is that fair to say?
Maybe. And we use it in other places too. Where I think mentally we're thinking right now about external attackers who are breaking in, but we've successfully deployed interesting approaches toward using user behavior monitoring and allowing the system to figure out and maybe even categorize, hey, I can tell you which department this person works in. And I've never seen their group information in the Active Directory, but I can tell you because they behave like everybody else who works in that department. And then the anomaly, and that person is now acting in a way that no one else in that department does. So what's going on over there? Which isn't necessarily the outside person. It's the insider who's been compromised, or some person who's just nosy and doing things they shouldn't be doing.
Yeah. So taking that kind of information that's there and exposing the anomalies, and then passing it maybe over to a human to do the additional contextual analysis to say like, oh, that is odd, but it's okay, versus that's odd and that's not okay.
That's right.
That kind of seems to be the sweet spot for ML where it exists right now. Okay, so let's shift now to talking towards learning this stuff, because I think you probably sold plenty of people on like, yeah, that's definitely something I want to do, right? I want to find advanced attackers. All this sounds great. I hear words like, neural network and all of that, and I see complex math every time I Google data science. Is this not for me? Is it doable? Like, where do people start with this?
When I wrote the 595 class, my goal in writing it and teaching it is to make it something that is accessible to anyone who has completed high school math. Which is interesting because you're right. There can be a lot of advanced mathematics in there, right? At one point, we have a slide. It's calculating the gradient of the n-dimensional tensor across. So it's this massive math terms. But when we teach the class, we work very, very hard in building intuitions about how the math works. I can teach someone who has basic high school mathematics, who's had some algebra. I can teach them the notion of what a derivative is and how gradient descent functions without them ever really needing to learn calculus. Now, of course, if you've got someone who's mastered multivariate calculus, that'll make the math even easier. But frankly, you and I are not going to sit down and calculate the gradient anyway. That's what the tool does. The purpose of giving the intuition about the math is to allow you to understand how your tool is functioning. And the reason that matters, I see companies that are selling these automatic ML stuff where you can just feed it data and it'll do it for you. And you may get good results, but you may not. If I don't understand how it works, how do I select the way it works? We'll give you a very simple thing, right? In the output of a deep learning neural network, one of the things you have to define all along the way are the activations to use. How it is that the data is going to be modified as it works through the network. Well, if you don't understand anything about how those activations function, you're really just guessing. And if you happen to get a good result, that's nice. By instead giving you the mathematics underpinnings and some intuitions about it, you can now make an informed choice and say, okay, all right, the problem I'm working with, because of the scale of the problem, because I'm looking at something that will do a prediction of, let's say, a continuous value. For example, one of our capstone projects is solving CAPTCHAs for both blue team and red team kind of activities. So taking a CAPTCHA and writing a CAPTCHA solver. Well, I need to figure out where those things are and get them in the right order to solve the CAPTCHA. So I need to figure out its position. If I'm trying to figure out its position, this activation over here makes sense. I don't really have to be able to calculate that thing, but I have an intuitive understanding of what it can produce. And I know that that activation over there would be absolutely wrong because it has no hope of producing what I need. So that's the level we try to present it at. We try to give you all of the math fundamentals you need, but you don't have to calculate it all. It's just so you understand what it's doing. Yeah.
Is this a field that you think there's an issue with, like, there's either people coming totally from InfoSec and they don't know the code side, or all the people, from the coding and kind of data science side are struggling with InfoSec? Is there one direction it's easier to go in, or, are people struggling to get that overlap? What do you kind of see there in terms of what preemptive skills people bring into trying to learn this and their success rates in doing so?
That's so interesting because when I wrote the blurb for the class and how the class was going to get marketed, we've gone back and forth about, is this a 500 level class or a 600 level class? And it's quite interesting. The feeling generally is that probably this is a 600 level class. However, if I said it's a 600 level class, the big problem is I can imagine a raft of data scientists coming thinking we're going to give them new and innovative ways to build some, and that's not what this is. This is all known technology. So the 500 level seems right. In marketing the class, I told SANS specifically, this class is not for, in fact, I think it says this in the blurb for the class. I think it says, if you are a data scientist who is actively building machine learning class, this is not for you. But the amazing thing is that so far, 50% of the class are data scientists.
Huh.
So half of them are InfoSec people who are like, I want to learn this data science stuff. And the other half are people with data science degrees and credentials, which fascinated me. And I'm sure you can imagine. I mean, should I be teaching these people this class? I mean, this is overwhelming. And it turns out that they all suffer from the same problem. How do I take information security data and how do I turn that into a data science problem? So more than anything else, that's probably the big thing that people are walking away with. How to reformulate what you have into something you can solve with data science. The only prerequisite we really have in the class is that you have written some Python code. And you don't have to be an amazing Python programmer, but we're not doing the fundamentals of Python. You should have written some Python scripts in the past, because the class is probably, I think in that blurb we say 50%. It's more like 80% hands-on writing code in Python to implement solutions. So it really is for any InfoSec professional who's done any kind of Python, and data science people who are struggling with how do I take my data science knowledge and apply it to InfoSec, because I just can't figure out how to do that.
Yeah, it always seems like an interesting kind of problem space, because it's rare to find someone that knows both sides of the field, kind of like you do, which is why you're probably the perfect person to write this course. And I've seen a couple of your night talks at events and stuff where you go through and do very, very understandable, simple, clear ways of explaining what would otherwise be incredibly scary and complex. And so definitely wanted to commend you for being able to simplify stuff like that. That's
one of my
awesome.
favorite quotes from a student was, "It made so much sense when you explained it." That doesn't mean they could do it later, but
Yeah. I mean, a lot of that is in how you explain it. I have an engineering degree, and I suffered through calculus the entire time. And then now, I can go on YouTube and there's this channel, I think it's called 3 Blue 1 Brown or something like that. I always forget the numbers, but I watch that. I'm like, where was this in college? And that's, when I'm watching that, I'm like, I feel like I'm watching you explain data science. It's just like they show the drawing, here's the practical, what you have to think about. And I'm like, well, that wasn't so hard.
One of the things I've had students say, it's actually been quite funny, because I don't view this as a math class. The math is ancillary, right?
Mm-hmm.
But I've had so many students write on evals or come up to me and say, you know what? I learned more calculus today than I learned in 3 years in college, which is not my goal. But it's a matter of how we teach math too. I think mathematics quite frequently is impenetrable to people just because of how we teach it, because we teach it as rules. And one of the things we actually start off telling people is that that's just not what math is. Math is not about rules. It's about what it's useful for. And that's what we try to convey.
Yeah, and that's definitely what I love about your approach on this. To start closing this up, a couple final questions. Is there one, or at least some space of problems where you're like, this is the thing that is perfect for this kind of problem approach? Like, is there one specific tech that you saw and you're like, blew your mind, right? Because it was something that was totally impossible before, now you can do it, or anything of that nature?
Really the biggest one to me is that it allows me to take a problem where, for me to solve it as a human, I would either have to write a lot of code as I'm learning about the data and writing more code, and take days or weeks to get through it, or alternatively, look at all of the data myself. And in doing that, I will almost certainly miss things. So more than anything else, the thing that motivates me and drives me to continue doing this is every time I do something that takes maybe 15 minutes to create, and it shows me a thing that would have taken me days or weeks to find on my own or get my analysts to find. And it was there to find, but it is the proverbial, where are the needles in the haystack? And I don't want people to hear that and misunderstand. I'm not saying that there are no more needles in that haystack. I'm saying that I've used this again and again and had it, here's a needle that I had no idea was even there. And that is just invaluable to me because it gives me new ways to think about approaching the problems. We did one just recently where one of the things we talk about in the class is something that's a more advanced kind of calculus-y signals analysis thing, Fourier transformations and doing a discrete Fourier transformation on data to find signals. And after class, I had a couple of guys who were very, very interested in that. So we spent some more time and they said, you know what, we've got some firewall logs. How would we apply this to a firewall log? We see what we applied it to in class. How would I do this with a firewall log? All right, so we sat down, we worked that out. Half hour later, we've got the thing running, and we've now got this visual showing us signals that are happening in their network. And they look at the data and they say, okay, now we know what those three things are. We know what those three things are. But those four, we have no idea what they are. So they spent the night working on that and reported back to me in the morning that they found 4 compromised things beaconing out to command and control stations overnight that have been persisting in their network for who knows how long. But here it is, one section of the class, a half hour after the class, there they are. Wow. I mean, it doesn't mean there's nothing else wrong, but that's useful.
But yeah, absolutely. That's a crazy feeling, when you're just like, I did this new advanced technique and there it is, right? And it's just like, yeah, it's no guarantee that it caught everything completely, but pulling stuff out of nowhere where you couldn't do it before, even if that's a kind of the general thing it can do, is an amazing thing for it to be able to do. People who want to get started on this, maybe see a little bit more information that you have out there and some of your talks. What do you have available that people can kind of follow up when they, after they listen to this and see and hear?
Yeah, every other Friday at noon Eastern, we do a live stream, which I don't even know what the official name of it is because my pet name for it is Dave's Python Fails. But we sometimes interview people. Just recently, we had Jess Garcia on there, who's heading up a really wonderful project that's focused about incident response and forensics and ML and AI applications to that, and they've got a whole distribution out for that. So we just had him on there, but more frequently, it's quick, short demonstrations, usually about a half hour to an hour long. We're currently doing a multi-series one right now that's just about understanding what a neural network looks like and being able to visualize it a little bit. So if you're interested in learning a little bit more about it, hearing some stuff about how this works and ways to apply it, that's certainly a place to go. There are, of course, there's tidbits in there that are related to the class, but I don't cover the stuff that's in the class. The class is much more intensive because I can't assume that in a live stream audience, people are going to understand what I'm talking about if I start dealing with the gradients and all that kind of stuff. So we try to keep it kind of light, but there's usually some useful, interesting stuff about understanding how the stuff is working. And sometimes things you can go and do yourself.
Very cool. And as of now, like you've got, I don't know how many of those done and kind of categorized up there, like 10, 20, 30. I have no idea at this point, but you've been doing them for a while. So a lot of good material out there available for people. Very cool. Anything else before we close up?
No, that's about it. If folks do want to join the live stream, one of the things I'm always asking folks for is suggestions of what they'd like to see. Because otherwise, there apparently are a bunch of people who are very happy to tune in and listen to me ramble for a half hour about whatever I'd like to talk about. But if they have specific data science or machine learning questions, or even just cybersecurity questions, just feel free to get them over to me, either via Twitter or through SANS. And I'm very happy to address those things there too.
Very cool. And what is your Twitter handle?
IT_audit. Yes,
right.
I know it doesn't fit. I oversaw the audit curriculum for SANS for like 20 years. So
that's one of those like awesome names that you must have had early on because it's so simple. There's no numbers on it, That's very cool. All right. Well, thank you very much, Dave. Really cool stuff. Looking forward to seeing where this field goes, where the class goes, and some of the kind of insight that you can help everyone, achieve through all these different avenues. You're kind of pushing this information out. So very much thank you for being on the Blueprint podcast, and we will catch you soon.
My pleasure. Thank you so much, John.